A lie detector test is given that it's accurate 86% of the time. What is the probability that the test will be accurate for 5 people? We'll start there. I do not know the correct percentage rate for lie detector tests, so I made one up. If you watch, what movie was that? Ocean's 11. They beat a lie detector test, which makes sense because it's based on your heartbeat and everything. But there's also visual clues, so you got to watch. So like if you touch your face, that means you lied. If your lip quivers, that means you lied. If you have pie gunk on your hands and you were asked, did you eat that pie? That means you lied. All right, even though the product rule is only defined for 2 events, E and F, it could actually happen for as many events as you want. So in this case, we have 5 people for both A and B. The question is, if a lie detector works for one person, does that mean it's going to affect it working or not working for another person? No, it has no bearing if it works on one person to another person. So because of that, we have 5 people. What's the probability it's going to be accurate for the first person? 86 over 100, or you could say 0.86. Either one's fine. And what's the probability it's going to work for the second person? Same thing. And the next person, and the next person, and the last person. So just because it works for someone does not have any bearing on if it's going to work for someone else. It is just like those weight loss ads. If I could do it, so can you. Not necessarily. Because I like pie. That's why. So this is really 0.86 to the 5th. What is 0.86 to the 5th? .47. Can you give me more decimals? 0.4. So that would be 47.04%. Yeah. One more time, please. Yes, 0.86 to the 5th, because we're multiplying 0.86 5 times by itself. Okay. B, the test will fail for 5 people. Well, if it works 86% of the time, then what percentage of the time doesn't it work? 14%. So we'll have our 5 people. Now, it may seem crude to write the 5 underlines here. However, that technique's going to be very helpful in the next section. If anything, it helps organize your thoughts. So I would get used to it. So we have 5 people. Independently, it could work 14% of the time for any one of them. So this would be 0.14 to the 5th. And what is this as a going to 4 decimal places? It's going to be really small. Oh my. So it's really, really small. Yeah, okay, so it's 0.00000537. So yeah, that's 0.005%. Okay, if we add part A's answer to part B's answer, we don't get 100%. So please understand that the opposite of working for all 5 is not failing for all 5. So the opposite of all is not nothing in this case. The opposite of working for all 5 is it doesn't work for at least one person. So please be careful with this. So we have 4 other cases. It works for 4 people, 3 people, 2 people, 1 person. If we found those 4 and we added to these 2 as well, that would equal 100%. So in the next chapter, we're going to talk about, well, what if it only works for a portion of those 5? That's called a binomial probability. So for right now, we can only do we can only do all or nothing. Later on, we're going to do part of them.